So what lessons can we learn by looking at more of this data? Putting it another way, you look at CO2 emissions here in grams per mile out of the tailpipe and look at the average speed. Okay, at very low speeds here and at very high speeds here, the emissions tend to go up. Here you're probably sitting in idling in congested places. Engine is burning very inefficiently, and or you're traveling in neighborhoods with very low speed limits or whatever. And up here you are obviously going beyond the efficiency range of the engine itself, where the highest efficiency for consumption of fossil fuel and horsepower output and speed, etc., is somewhere in this range, whereas here you are gaining speed by being very inefficient. Okay, so this gives a nice kind of a bucket here with minimum emissions in this speed range. So that gives you a way to think about how you would want to do congestion mitigation at this end versus speed management at this end. So the real world activities and steady state activities are shown here in terms of the data from let's say in the lab versus the real world, testing chambers and so on. And the traffic smoothing is going to bring in the congestion down and the emission down up here, and speed management is going to move the emission profile into the minimum range down here. So basically you want to aim for traffic management and congestion management to bring the CO2 emissions somewhere in this range. But obviously there is a need for speed by some people, either to get fast from one place to another or just cruising for the fun of it out there in the vast wide open spaces with nice big roads where you can go flying. Okay, so results from these sorts of figures tells us that if congestion reduces the average vehicle speed below 45 miles per hour, in the US we always go miles per hour, for this particular freeway scenario, emissions increase. At these lower speeds, vehicles operate less efficiently and spend more time on the road, resulting in higher emissions. In this scenario, congestion mitigation programs will directly reduce emissions. We'll see what the caveat associated with this is in a minute. Well, let me just show it to you. This analysis assumes that the travel demand won't change when congestion is reduced, because there is some evidence that if somehow congestion has been reduced using some method, then there is latent demand. People who avoid traveling because of congestion say, hey, there is no congestion, let me jump in the car and get on the road. So this induced demand or rebound effect will be discussed again a little bit later. The second point is, if moderate congestion reduces average speeds from a free flow speed of 70 miles per hour to a slower speed of 45 to 55, this moderate congestion can reduce emission because emissions are higher and energy efficiency is lower at very high speeds, as I mentioned already. With no congestion, average traffic speeds can increase to over 65 mph and again increase the emissions. Okay, so there is a speed range where you have the optimal situation of trying to control congestion and keep the emissions as low as possible. Smoothing stop and go traffic will reduce emissions, obviously, because every time you slow down, idle or cruise at a low speed and then accelerate, you are going to burn more fuel and increase emissions. Electric vehicles powered by renewable energy will have near zero life cycle emissions. That's the goal. If electrical life cycle means including where the fuel is coming from, how it's transported, whether it's hydrogen or fuel cell or electricity. If electric vehicles are powered by fossil fuels, emissions from power plants will be lower at lower speeds for the same reason as for combustion engines. but even more so because regenerative braking captures energy in the stop and go traffic. So there is the design where when the engine is spinning, it can actually charge the battery. That's called the regenerative braking, and it seems to work in terms of capturing the energy in the stop and go traffic, which is really bad for fossil fuel cars, internal combustion engine cars. Okay, this I already mentioned. So these are the kind of subtle data that one has to collect, look at the traffic patterns, design intelligent transportation systems, we will see later on, to forecast congestion, manage maybe the loads on the roads, and reduce emissions. So again, we can go back to the idea of command-based regulations, policies versus market-based policies for traffic as well. But we're just going to focus on managing sustainable transportation with these kind of ideas and not so much policies.